Good morning. We're going to talk on Module 16 on disinfection. What we're wanting to do is just kind of get an understanding. We talked a little bit about some of the processes that we're using for disinfecting the water. Why is it important? What are we trying to accomplish? And then some of the different techniques that we can use for disinfection. Of course, what we're going to look at, we need to look at the microbial components of the water, especially if you're using surface water. You got a lot higher probability of having pathogenic organisms versus groundwater. And then we're going to look at chlorination. We talked some yesterday in Hickson about how a lot of people are moving away from chlorine. You know, I'm a chlorine guy. We have tons all over the place, hazmat certified, safe, emergency response, all that kind of stuff. So I love chlorine, but there's an inherent danger in using chlorine, and so depending on the size of your system, a lot of people are going into the, where they're using bleach or they're using some of the other techniques. Texas is real big about using chloramines if you're using surface water treatment, so you don't have some of the disinfection byproducts. But from what I understand, y'all are really shying away from chloramines and chlorine dioxide.
Not so much chlorine dioxide, but chloramines, yeah.
Yeah. So there's pros and cons to everything that you use. I mean, having that 1 ton cylinder of chlorine, and you can put some hurt on some water demand. But you also have to think about your community. You have to think about your employees. There's a lot of things. RMP program, risk management program. So there's a lot that you have to think about. And then we'll look at some of the alternative disinfectants, especially out in Arizona. They're using a lot of ozone as part of the treatment process. Real expensive, really great disinfectant, but there's some other issues with it too. So pros and cons about it all. Start looking at waterborne diseases. What do we need to really be concerned about? What are we trying to accomplish? And the main thing is we're not trying to sterilize the water. Very expensive and not necessary, but we do want to get rid of the pathogens. We want to get rid of what's going to make people sick. Again, sterilization, we're going to kill everything. I just came from the Virgin Islands. We're talking a little bit about that. They use a desal process, and they use that for their energy generation, and then what's coming off of that they're able to use for their desalinization of their drinking water. So they're at that temperature, you're killing everything. And in fact, they've got squeaky clean water, at least in the plant. The distribution system has some issues, but because of the age of the infrastructure. But the water coming off of that process is really clean. You're taking care of all your demand just by the inherent process that it has. So, like we mentioned about, we're not trying to test for all organisms. We're not trying to sterilize the water, but we do need to make sure that we're not going to get people sick by it. As we know, we've got a lot of microorganisms in our body. We've got them all in our environment. But the thing that's critical is that most of those aren't going to make us sick. In fact, they're real helpful. You get a stomach bug, you mess up your flora and fauna in your gut, and you feel it pretty quick. And then where do most of them come? The ones that are harmful for us is coming from warm-blooded animals, intestinal parasites. So if you have fecal contamination of your source water, if you don't have good wellhead protection, if you have animals around at all, you can wind up with a lot of problems. In fact, it's one of the big issues that they had in Milwaukee. This is the 20th anniversary of the outbreak of Cryptosporidium in Milwaukee. And their watershed had a lot of animal usage around. Large rains flushed it all in. Didn't have properly trained operators. Really didn't understand their plant processes. Didn't know about their filters and all. Had breakthroughs through their filters. And they're just sending that water on. As we know, Crypto and Giardia aren't inactivated by chlorine, so we need to use other techniques. And so they're sending that off, and wound up having over 100,000 sick, and a number of people died because they didn't recognize the process, the problems with the process. And so part of the Safe Drinking Water Act, one of the big ones was operator certification. And so that's a really important, training and competency is really important. So we're looking at some of the different types of diseases that are in unsafe water. Luckily, we don't have a lot of this anymore. We hear about Montezuma's Revenge and things like that in some of the third world countries. Occasionally, we'll have some outbreaks. Haiti was a big one. not too many years ago when they had the earthquake down there. It wasn't, their people got hurt and injured and perished from the buildings collapsing. But the biggest threat to them was with their compromised infrastructure, water and wastewater. A lot of people wound up with cholera, and that was a huge issue for them. That killed a lot more people and made a lot more people sick than the actual physical effects from the earthquake. So luckily we're getting a lot better on our treatment processes as a whole, and we're even able to export a lot of that to other countries. They're looking to the United States and Europe as the trendsetters for these treatment processes. And so we're really at the forefront in a lot of ways of providing this public health. Setting the standard pretty high. We talked about we're not testing for all organisms. Obviously that'd be very expensive. Some of the tests are very difficult. So what we want to do is we want to be able to determine what's in the water, easily identifiable. Everybody's doing presence absence tests for total coliform and fecal coliform. Are you all certified in your lab to test? Excellent. Do you actually test yourself? Excellent. So you do proficiency tests? Okay. Yeah, I was certified in the lab too. That was one of those we talked about that, if you play with numbers in certain areas, you get your hands slapped, you start playing with a bacteriological sample, that's kind of the go to jail stuff, and so it's really important they take it that seriously. So when we look at our indicator organisms, we're going to test for certain things. The total coliform group is the main group that we're going to look at for our total coliforms and then our fecal coliforms, and then we can drill down even further. We can look at our E. coli, and that's going to give us a good indicator of what kind of fecal contamination we have in our systems. And so when we start talking about distribution, we want to make sure that we keep our systems separated as much as possible. The source water, knowing what's in your water, what's in your watershed, is a big impact on what's coming into your intakes. And wellhead protection, for those that are doing groundwater, y'all have small groundwater systems there that y'all are using? Okay, so you got a well pump. Wellhead protection is huge, critical. Abandoned wells is a big issue. Having those out there in the system that are out in the middle of a field somewhere somebody had 50, 60, 100 years ago. Nobody knows about it, and it's an open source of contamination into your aquifer. And then of course we talked about it's the warm-blooded mammals that are going to give us that susceptibility for fecal coliform contamination, and so that's what we're trying to test for. And ultimately, we want to minimize the people getting sick. I take it real seriously. We talked a little bit yesterday about the who's pulling your samples, how are they trained, are they certified, are they doing multiple types of samples? So we had an issue with our system in their infinite wisdom. They were going to have people pull in industrial waste, go ahead and pull their back tees also. I mean, it's just, you got to keep those things separated.
I had an experience where a water system called and they had a positive, was E. coli positive, and I started asking questions about, well, where'd you pull it from, who was the sample, and stuff like that. And it turns out the sample was a person from the wastewater plant. And so I was like, well, definitely don't make them collect the repeats. So yeah, I mean, it's just a story out there.
Yep.
While we're on the subject, how strict is the sample pulling? I mean, can I have my crews just pull the samples while they're out there? I mean, even though they're not qualified or licensed?
As long as you feel like they've had the proper training. I mean, definitely don't want somebody that's never done it before to do it. But if you had like a little training session or something like that, show them, hey, here's where you want to type site that you want to sample. We don't have a requirement that the sample puller has to be certified or have to be approved or anything like that. But definitely you want to feel confident that, hey, I've watched them do it. They know where to
They don't know how critical it is.
Exactly. So as long as you're comfortable with them doing it, I mean, we're fine with it. So.
And the biggest thing is ultimately, if they're pulling bad samples, it's on you.
Yeah.
So it's to your benefit to teach them how to do it properly.
Right.
And because, I mean, the whole thing is, we wanna make sure that the water we're sending is appropriate. You know, you don't wanna circumvent, because it's easy if you chose to circumvent the testing process, which is obviously not appropriate. So, but yeah, training is huge. In Texas, you have to be a licensed operator to pull samples.
Okay.
But that's here, if they're letting supervision of a licensed individual set it up, I would certainly look at an 8-hour training course or something like that. There's a lot of information available. TEEX actually does like, and I know other states too, they have an 8-hour sampling course for either water or wastewater. They go in and talk to you about the different types of bottles that you would use for different sampling techniques. Where do you pull them from? When do you not pull them? You know, that's just as critical as pulling a good one, is knowing when you don't pull it, because you're gonna have a high risk of contamination. You know, we had Arizona, they had a sampling site, and we'll get into sampling plans and stuff, site sampling, but here's this house, and the house has been vacant for how long? They just did work on the pipe in the yard, and they're out there pulling the sample from that. Well, obviously, there's several things that are wrong with that sample site now. So you need to have alternative sample sites. You need to know when is it a good time to do something at a different location. And it can be as simple as some wording with, you know, you have an address and you say in the vicinity of. So if you take it next door, upstream, downstream by a house or two, you're still getting a good representative sample. So, yeah, it'll be, unfortunately, be on y'all as a utility if you have somebody out there that's not pulling them well. And we had a situation where we went through that. Somebody went out and pulled a bunch of samples that used to be Kelly Air Force Base. They had their own little water system, and it came under the jurisdiction of the city after they did a base realignment. And somebody went out there and sampled, and they pulled 15, 20 samples. And I was in the lab that day pulling, you know, doing the results, and I had like 10 or 12 positives for total coliform. Luckily, it was just total coliform. But we had to go through all the paperwork of getting them invalidated by the state, all the repeat samples that had to go on and on and on, because somebody didn't understand the process. So that's a, especially for back tees, I'm a real stickler. We had a question yesterday about wearing gloves. I would highly recommend against wearing gloves. Make sure you disinfect your hands well. We're going to get into it on the system, but make sure you disinfect. What do you do for disinfection on your tap? They asked about Lysol. I personally wouldn't like Lysol to be used. I prefer a bleach solution in a spray bottle. Most people aren't flaming anymore. You know, there's plastic components and stuff that try to rubber, you're gonna, the seats are gonna melt and stuff. But a good proper disinfection, a good flushing time, all of those are real important for them to have a good understanding of. So, but yeah, when I was in, I don't know how you feel about micro in the lab, but when you're in the micro area, it's so easy to get your gloves contaminated and not know it, and now you're touching everything. So we just didn't use gloves in the micro portion of it, everything with bare hands. And you knew if you had a drop on you, you know, you washed your hands real regular. And that's what you need to do out in the field as you're sampling too. Whoever's doing that sampling needs to make sure that what's in that bottle only came from that water, not any other source. And they're easy to contaminate if you're not paying attention. Even something as simple as how you transport them. You stick them down in ice. You know, you put them in a plastic bag before you put them in the ice. Do you have the blue freezer packs or something like that? Because you can potentially contaminate that sample bottle. If you have an ice chest, the ice is starting to melt, it's kind of floating around in there, you got your bottles dropped down in there. You know, so those are just things to think about when you're, how do you preserve your samples? How do you preserve the integrity of it? Then we looked at in the book, it'll talk about some of the number of samples required based on your population. Right? We just talked a little bit about the sample siting plan. Obviously, we need to know our distribution system. We need to know how do we represent it well. How many samples are you pulling a month?
10.
10?
10 just for back tees, not
Yes.
one.
Okay. So, do y'all have somebody go out there, you front load it at the beginning of the month? Do you spread it out evenly throughout the month? How do you?
We break them up in sections and try to spread them out throughout the month.
Okay, now do you pull off from one section at like 1 week and another section, or do you try to
We
hit?
just zigzag everywhere.
And that's excellent. That's really what you need to do is, again, our management and their infinite wisdom, they said, well, and San Antonio's big. Well, here's a section, let's do this section all in a day or two. Then we're gonna move over. But you're not representing your system well. You need to have people going out into the various areas throughout the week, pulling those samples, so you really know what's happening system-wide. Because you can have, we talk about hotspots in our area with disinfection byproducts or residual issues, flushing issues. So we really need to be able to identify those and pull well from those different areas to represent. And wording is real simple. When you look at your sample siting plan, if you have that language in there that you can pull in the vicinity of something, that gives you that flexibility. You don't have to have so many extra alternate sites. You've already incorporated it in there, which is the language. Is that appropriate?
Yeah, but we've, most of the systems, I think, maybe do like zones,
Mhm.
and then we'll just randomly pull within that zone.
And that makes it
all
real
that.
simple. Yeah. Now, do y'all have designated homes that you go to?
We usually do, we'll hit a lot of the, we ask the customer if it's all right if we pull it from their home, and a lot of them will hit the same zones, unless we say they've got work or something, then we'll go to another house close by.
And usually whenever we look at, if they do like that, we look at, is if it's a specific site, again, are the sites representative across the system, and not just, hey, we've got 10 sites over here in this one area, and that's where.
Yeah, right outside the door of the plant.
Exactly.
Yeah, first point of use. So, but yeah, that's, a lot of times they want you to try to take it from the same location because it's benefit, because it builds that consistency. Not always possible, so you need to have flexibility. But if you're able to designate in a zone specific homes, that's very beneficial from my background, my perspective. Yeah, consistency is really important in your sampling, in your locations, in your techniques. So we talk about representative sites. We do need to look at our distribution system, looking at our maps and seeing where we might have issues with water age. AWWA did a neat article not too long ago on hydraulic modeling of distribution systems, looking at water age, because water age plays into a lot of water quality issues. Your chlorine residual issues, disinfection byproducts. And there was a real neat article on, and not everybody has the ability to go and model your distribution system, but just something as simple as regular valve turning and all can help you understand what should be open, what shouldn't be open, because it's easy if somebody go into a repair, close a valve, and now you've got a leg that used to be in a loop, now it's a dead end. And now you start, why are we having these low residuals out here? You might have a valve closed out in your system, something real simple. So part of your PM program, and I don't know if y'all are doing that, I know it's hard sometimes, but valve turning, getting somebody out there. And if you can do something other than manual, I have plenty of manual. If, do y'all have any hydraulic valve turners?
Do what now?
Hydraulic valve turners. One of the things that they have truck mounted units, and that takes just one person. And it's an investment on the front side, but I think in the long run it saves you because your valves work, they're getting exercised properly, doesn't take a lot of manpower, person power, to get out there and actually operate your valves through the system. And if you have it set up on a regular program, then you can go and you can turn on your valves, you know what your valve position should be, and it can be real beneficial. So, we had 60-inch valves at the ASR facility, and after me out there turning a bunch of them a couple of times, I started looking online for hydraulic valve turners. So that was you have to be careful with them, of course. You got to know how to operate them properly, but they're very beneficial, and especially if it's a truck mounted. Pull up, throw your key on there, and it actually it'll figure out what direction it's supposed to be, and it'll work them if they're they work under real low pressures that increase pressure as they're operating them and stuff. So be very beneficial as part of the PM program. And I know if you're worried about just keeping a pipe in the ground that's not leaking, that can be kind of a pipe dream. But as a system, that's some of the things you have to try to move toward. Y'all have a regular program for valve turning?
We try to do maintenance on the valves, but it's hard to valve maintenance. I mean, we can strictly, as the gas is a mandatory thing that you have to do every year, but now on the water side of it, it's I'd like to see it get that way, but at the same time, having the manpower to be able to break loose and do it is another problem, but.
That's what we're finding, I mean, just everywhere, I mean, there's systems that wanna do it, but they just don't have the manpower to get out there and have a regular valve exercise and program.
Yeah. But you know, some of it, if you don't have to have 2 or 3 guys going out there and turning valves all day, if you could have one person go out there and drive a truck from site to site, how many more are they gonna be able to do in a day? At the end of the day, they're gonna actually come back the next day. They're not gonna be so tired that they're done. You know, so I mean, those are things that
Have you ever had any problems on things, twisting the valve too?
You can, we had a manual one, handheld, and it was a 2-person. You have to understand how to operate the equipment. You know, you get people in there, they're gonna crank it up on, you know, foot-pounds, and man, they're torquing it out. Well, yeah, you're gonna twist stuff pretty hard. But if you get into a regular program, and the good thing about like the truck-mounted ones, they run off of a PLC program, and when it starts to turn, it actually starts off at real low torque, and it starts to manipulate it. And then as it starts to feel that resistance hit, then it starts to increase slowly but surely until it finds the direction that it needs to go. A lot of them you can program in the valve size, so it knows about how many turns it needs to run. It'll slow down as it gets to the stop. They're really neat programs. And you can probably get one, I think, truck mounted maybe under $1,000.
Oh, really?
I think maybe 3,000. It's been a while since I've looked at them, but it never hurts to investigate and see. I know they had a real nice trailer mounted, which was like $20, but that's because it had a vacuum system going, and you could power wash out and something that we had a lot of issues with sand. But yeah, look and see maybe that one cost about $5,000. But if you look at long-term, how that's gonna benefit you and your organization, you do a cost-benefit analysis versus how often we have it out there, having to repair or extend your shutdowns because you can't get a valve to isolate. You know, how many times do you just say, just keep going?
Yeah, and shut more often than you do.
Because your valves are, you know, and it's that time that you really have to shut something off that you figure out that it's not working right. Yeah. So on the gas ones, are they underground?
The gas valve?
Mhm.
Yeah.
And
Yeah,
so
they're just quarter turn valves, but
Okay.
they have to be, every year you gotta document it, and you gotta turn them 1/8 of a turn. I mean, you don't shut them completely off, but they
Right.
gotta be able to turn, and then you gotta record them and document it every year.
Yeah, and that's a lot of man hours in itself, right?
Oh, yeah,
We shut
it
it
takes 2 guys, probably 3 months to do the whole system.
Yeah. Yeah, I understand it is about how many people is it gonna take to do something, how much time are you gonna tie up? But there's also that component of, if I don't do my PMs properly, what's it gonna cost me? That's a big issue when we get into, like on the distribution system, on your pumps and motors and all. If you're not maintaining them properly, if you don't have some sort of a preventative maintenance program, you have catastrophic failure, now you're really up the creek trying to scramble and get stuff going again. And it would normally costing you more in the long run by not having a good program. So those are just some things that, from my experience, that have been beneficial when you start looking at. And I know we kind of got off of the back T, but distribution is real important, and it's all a big component of it. So if you have 5 samples or less, you said you ought to pull up 10. So you have 10 distinct sites that you're pulling from. We need to make sure EPA recommends that there's an actual physical address. Not only that, but we deal a lot down in the Virgin Islands with them pulling from condo units. Well, not only do you need to specify the unit, but you need to actually specify the place in the home that it's being pulled from, and designate that as a sample site, kitchen 1 or bath 1, something, so that it's easy if you have to go back and do repeats, you know exactly where it's pulling from, you have that consistency. And you gotta have the information available for the state. For the NTNCs, non-community, non-transient populations, it's gonna be based on the daily population. They're gonna need to select something in the business, especially like the schools and all that are running. They need to be able to, again, designate an appropriate sample point. Try to stay away from blending valves on their sinks and all, because then you're getting from your hot water heater being pulled in. The little recreational areas, I know that especially some of the rural parts of the state, you got the little mom and pop places out there, and they're trying to run the general store and push water and everything else. So that sometimes they don't have that technical knowledge to be able to set a good plan. Distribution maps, I don't know if y'all are getting into GPS locations, and that's an awesome way to go in and easy handheld devices, tell where your valves and stuff are.
We've got all of our meter boxes now with the GPS, because we went to the AMRs, and now we're losing our meters because the grass is growing up over them, so we don't open them to read them. So now we're GPS and all of them, so if the customer has a problem, we can just take the GPS out there and make sure we're time to meet.
Excellent. Yeah, we're gonna get into, on the distribution part, we're gonna get into the AMRs, but how's that working out for y'all?
Oh, it is working great.
You like it? Yeah, I know on the customer side, there's a lot of concern because the bill's a lot higher, but it's probably actually more accurate.
And it's helping with the water loss, and it's also, it's just the manpower going to read the meter. You can read in a month, every month it used to take 2 guys, probably 25 days to read it. Now it's taking 1 guy for maybe 12 days.
Are they doing a drive-by and it's just reading in the
Yeah,
vehicle,
yeah.
or is it sending it all the way into?
No, they drive by.
Okay, so they're getting a drive-by reading off of it? Yeah, they were just getting ready to do that in the Virgin Islands. They had a group out of Colorado go down there, and I was talking to the guys. And one of the things that they have is, it's a little, display that the homeowner puts on the refrigerator. And so they're getting feedback from the, metering system, and it actually shows what kind of usage that they're having on a monthly basis. It has a couple of different displays, and it helps with conservation. They can kind of figure out, when am I really using a lot of water? I guess it just puts it into their mind every time they go to the refrigerator. They've got that in their face as opposed to something that's out there buried underground. So.
One thing that helps us out is like if you got a customer call and say, there ain't no way I use this water. We go back and do reports on the meters now, and it shows what time they started using it, and what time they quit using it, and say, hey, this is the time when you started using this water. Then they're like, well, maybe that's when the garden guy come by or something, you know what I mean? But I mean, then they change their story. So where before, it's just your word is there.
Yeah. And you know, when you start looking at revenue, that's a huge, has y'all's revenue increased after you get in the system?
Yeah.
And, you know, there's still some issues with accuracy. There's some concerns and stuff from different groups. But, I mean, you know, we talked yesterday about being able to account for our water accountability. That's a huge issue. And there's a lot of sources that we lose water from, and being able to document that is really important. So, yeah, a lot of people are going to the AMSs to determine. And then it just has some different examples in the table there. Collecting samples, how do we collect our back tea? We need to make sure that we have appropriate sample containers. Y'all are getting them, you buy them right, sterile, it has your sodium thiosulfate in it already. We need to go out and make sure that we know how to pull the right sample, how to flush, how long are you flushing before you sample, pulling your chlorine residual, how long do y'all flush?
Yeah, it all depends on how, are you talking about for like a repair or just?
No, for your back teas, if you're gonna go out and pull your samples.
They usually flush about 15 minutes to half hour.
Usually they try to wait till the water stabilizes and temperature and stuff like that.
So you're waiting for temperature change. If you're pulling from homes, normally about 5 minutes, depending on, you know, how far your main is, how far it's set back, how much usage is in the home. But yeah, temperature change is a big thing, making sure you have a good residual before you pour your sample. Knowing how to disinfect it properly, knowing what size, you know, kind of stream you want. Pencil size, you don't need a full volume coming out, splashing all over the place. Rainy days, windy days are issues. Especially if you're out in the area where you have a lot of pasture on, wind blowing, it's an easy source of contamination. So I don't know if y'all consider that, but those are things that can be a hindrance to your sampling. Talk about flushing the line. Like I said, most people aren't flaming anymore, but a good bleach, dilute bleach solution is beneficial when y'all use some bleach. Or yeah, they were talking about Lysol yesterday. I don't know what Eric thinks about it. I was like, nah, not too.
I think, I mean, I've never heard of anybody using Lysol, it's always been bleach.
Yeah.
Um,
And then, because it was supposedly easier to carry it around, because the bleach over time will corrode your springs and stuff. I mean, you can put it in a squeeze bottle from the lab. It doesn't have to be a pump bottle. It could be just in a squeeze bottle.
Yeah.
You know, let's see, I'm a big fan of. I don't know what other kind of components are in there in the Lysol.
Yeah, that'd be my concern would be if there's something that's in there, I mean,
Yeah.
I'd probably just stick with bleach.
So my recommendation is spike a sample and see what happens, you know, and if it comes back negative, you got an issue, you know, but do some testing before you make that a regular part of your process, you know. And always discuss, because yeah, that kind of wouldn't be my first choice of as a disinfectant. When we fill in the sample, we're supposed to pull how many mils? 100 mils plus or minus about 5. How many times do we rinse the bottle? 0. Right? And it's interesting, a lot of times you say, oh yeah, you rinse it a couple of times. No rinse it. Not those samples. In the lab, normally when you're doing certain types of sampling or testing, it's 3 rinses is the norm in the lab. Not for back teas, not for anything that's been preserved, lead and copper, things like that. Chain of custody form, very, very important. I mean, that's what shows that the integrity of that sample from the point that it's collected to the point it goes to the lab. Even if it's something that you have your field out pulling samples, you ought to fill out chains of custody. Is that correct? Really important. I had some people in the Virgin Islands asking about if they could start pulling the samples themselves instead of having a contract come out and pulling it, because they're looking about saving money. But if you take that responsibility now of, you know, if you're pulling the sample, yeah, you're saving here, but you also have a lot more responsibility. And it's easy to get caught in a bad situation if you're not pulling the samples properly. So sometimes it's easier now, if you're certified, you have, you know, well-trained individuals, that's great as a utility, but just, you know, an individual out wanting to pull samples on their home could be a real problem, you know, or on their small system. And that's what they have out in the Virgin Islands. Every hotel, every condo unit, every restaurant almost is their own system. You know, you got a small island, you got over 300 systems. You know, and that's because everybody's got their own, and everybody wants to save a buck. And what's the consequences? You all pulling your own samples? Okay, you pulling them and you sending them off for?
Yeah, for the state lab.
Okay. You all shipping it in the mail, or are you able to?
No, I drop it off.
Oh, is it close enough to drop off?
Yeah.
Good, very good. How fast y'all get results back?
No week.
Is it? Okay. Do they call you? Do they send you a report? Huh?
They send me the results.
Okay.
If it comes back positive, I think they'll try and contact you whenever they
Right
get
away.
results, but as far as the paper
Yeah.
result, or the paper results, it's.
No news is good news?
Exactly.
All right, excellent. Yeah, and that's one of the issues, even on positives in the Virgin Islands, it could take 5+ days before or actually 5 days was like really good. And it's like, you know, there's telephone, there's email, there's a lot of ways that you can contact, so you start pulling your repeats and stuff like that to make sure you're not having problems. Okay. Within 30 hours, so a 6-hour hold time on microbials, and then a 24-hour transit time that they give you in case you have to ship it off somewhere. So 30 hours, really the test should be run at that point in time. Have to have a sterilized container. Sometimes people, you know, add their own sodium thiosulfate. It's so easy to get it with the tablet in there now. Just don't have to worry about it. We know how much the sodium thiosulfate tablet will neutralize how much chlorine. Do you have an idea?
About 10, 15 parts per million.
About 15 is what IDEX talks about. So you know, if you have a pretty hot sample, you can still neutralize it. They really go above and beyond. You shouldn't have that much out in the distribution, but if you're pulling special samples or something, construction samples, you can still get away with having an elevated residual. Obviously, we don't want to overfill it. If you do, get a new one, start over. You're done with that one. And then we talked, Tennessee is interesting with the way the sampling is. Normally you'll have your regular distribution samples, your construction samples, and you might have a special sample. Well, if it's something that actually has water going through it to somebody's home, now it's all part of your distribution sampling that goes into your CL. and-
That was something that came down from EPA.
Is it?
At one time, we were saying that, special samples were line repairs,
Mhm.
and it wouldn't count towards compliance, but then my understanding was EPA came in and did an audit and saw that we were doing that and said, well, no, if you put this line back into service, it's a compliant sample, so it's gotta be counted as a deed. So we made that change back in, I want to say 2005, somewhere around there, that we stopped allowing line repairs if they were put back into service to count as special.
Okay.
And that was, my understanding was that came from an EPA audit on that, so.
Interesting. Yeah, see, we were really trying to push, our distribution system, and it's a huge one, especially during the summer, a lot of main breaks and stuff. But we were trying to push them to be more responsible on sampling after repairs. Because, it's all about the numbers, it's all about how fast can you get to the next job. And then, of course, we have them come in and it'd be in a empty Coke bottle or something like that. They'd bring in the samples, or if they actually did pull it in a right back tea bottle, it had been sitting on the dash for 2 days, things like that. I'd have them come in and go, I don't see anything in there. You must have some great eyes if you can see your microbes. We had issues with them coming in with wanting to do a chlorine residual, and it's 15-minute hold time. Sorry guys, I can't tell you 3 days later out of a whole Coke bottle what your residual was out there in your system. But a lot of it is knowing your system, knowing what the requirements are, knowing your sample types. So, that's interesting as far as EPA mandating that. I'll have to ask somebody in Texas, because I know for a while there they were able to keep those as distinct sample protocols.
I mean, from what we were told is that if you're sampling water that's going to be used by the customer before you know the results are known, it's got to be a compliant sample. So that changed because we're allowing systems to code line repairs and customer complaints as special samples, and they wouldn't count towards the monthly compliance number. And they came in and said, well, no, if it's water being used by the customer, then it's got to be a compliant sample, so it's got to be considered a deed sample.
I'll have to ask somebody in the lab in San Antonio about that. That's interesting, because they have a big water quality group that anytime you get a customer complaint, they're going out there and they're pulling residual. A lot of times they're pulling the back T, depending on what the complaint is. Just the sampling side stuff. So I'll follow up on that, because it's interesting to see if it made it to Texas or not, or if they just like Tennessee a whole lot.
That could be that.
Yeah, but you know how it is when they come in. It's interesting when they do an audit, just like if you do a lab audit. When they come in, it's interesting to figure out what their pet peeve is or pet project of the week or the month is. So what are we doing for positives? You got to repeat from the sample. You're gonna do one up, one down. Y'all doing source water? Y'all having to do anything on
On true
your point of entry?
True groundwater systems that opt not to do the log removal,
Okay.
then they've got to do a source water sample. That on surface water, there's no source water sample requirement.
Okay. Is there any point of entry into your system, or is it just your upstream, downstream?
It's just
distribution?
upstream, downstream, and
at your
original
source.
site.
Okay, yeah, original site, okay. Yeah. In San Antonio, they had designated several of the pumping stations that was for the for log removal compliance. So that was a big issue on all the trending and all. And then if there was a positive out in the system somewhere, we had to go back and figure out what pumps were running at that point in time at those stations, and actually had to go out and sample.
Now, that may come into play whenever we go to the revised call formula where they have the level 1 assessment, level 2 assessment, where I think that talks about where you go back and trying to figure out where did this positive come from, why did it happen, and stuff like that. So that may come into play whenever we go to that. But right now, we don't have, other than just the original and upstream and downstream, we don't have any other required sampling for repeats.
So when you look at your SCADA systems, I would imagine y'all are running, do you have SCADA?
That's on the wish list.
Is your SCADA calling on the radio? We had the ASR facility was initially was about, I don't know, $3 to $4 million project between the plant on the well field, and then we had a big upgrade, it was probably $600 to $700 million facility. overall. And our SCADA system was Nextel's, so we'd give it a click on the mouse, and had a really awesome looking SCADA system. Click on the mouse and you call it and say, yeah, go start that phone. And go over there and you push the button. Because when they were trying to do the integration, it didn't work well. And we used to joke that if you're out driving in the well field and you saw a pigeon pick it up, it's taking a message out. You know, that was our SCADA, was a carrier pigeon and stuff. So systems are nice, and you can do a lot with them. They can be a real headache at times, but especially for data gathering, awesome opportunity for data gathering. And sometimes, depending on what you're using, if you're using any process logic at all, you can sometimes do that more locally, where you're gathering some of that data. I don't know if y'all are doing any distribution pressures. Do y'all have any pressure sensors out?
Keep up with the work orders on the water tap.
Okay, so you have somebody out there physically going out and writing them, and then you have them entering it into like an Excel spreadsheet or something, so you can trim them?
No, it's not the work order. I mean, now we've talked about, now that we're GPS and that we're
Yeah.
gonna start putting it on a PDF map where we can keep up with where all the pressure is.
Yeah.
and both,
And even if you have somebody out there handwriting on paper, if you can have an administrative assistant or somebody that's putting it into a spreadsheet and, you know, designate certain zones or whatever else, that way you can trend it. Because, man, it's also, I mean, that's when things really jump out at you, if you're able to see it in a map,
Right.
you know, see it in a trend. As opposed to, you can look at numbers all day long and kind of get lost in them, but if you see spikes or real major dips and stuff, that can be real beneficial. So if you just have the one sampling point, then they want it either on 4 consecutive days or throughout the day at that location. Invalidating, anybody had to invalidate samples?
If one.
That's pretty good if you only had to deal with one. What was it? You remember what the issue was?
They got it at a blow off, and they deemed the blow off to be bad.
Improper sampling locations. Very good. Yeah, we had to go through a big process when we had all those positives. That was a long drawn out affair, but we were able to at least get them off of the record. Of course, we blew the MCL for that month because they still counted in there. But so if your repeats are negative and you can have a good explanation of why you think that it was a positive, then you can go through the state regulatory. Are you doing that here for your region?
Yeah, we do it at each field office.
Okay, so you have in-house compliance monitoring?
Well, I mean, the results will come in here, like if a positive occurs, the lab will usually call us and say, hey, we've had a positive, or you know, this system had a positive. And then we'll go out and do the repeats, and then we'll follow back up on that. And if it meets the criteria for invalidation, then we usually ask, we'll go back and investigate, see if we can figure out, is it a domestic plumbing problem or something else.
Yeah.
But we do ask them to provide some type of data to show, hey, this is not representative of the system. But that's all handled within the field office. Depending on the situation, like if it's something that comes directly from the main or something like that, where, hey, it's no interior plumbing issue,
Right.
then that will have to go to the central office, because then we'll have to explain it to EPA, why are you invalidating a sample
Yeah, yeah.
from the main.
Yeah, if you got a tap right off of the main, then you got an issue. Yeah, that's understood. So do y'all actually go out if there's repeat samples to be pulled? Do y'all go out and
No,
not enough
we'll
time?
just talk with the water system and what you find and all that. So.
Okay. The obligation?
I mean, there's been, if there's like a real serious issue, like if multiple positives and stuff like that, we'll probably go out and pull samples ourselves to see, hey, is there maybe a sampling technique or something like that. But for just the routine, hey, we got a positive, we usually don't go out and do the sample.
Right. Understood. Yeah, it's all about time. No matter
Yeah.
what seat you're sitting in, it's always about time. Of course, we just talked about, you got to contact regional to get their input, their assistance, and even though if they're invalidated, they're still going to be in your monthly. So if you're having issues, if you're not pulling the proper samples, not repeat sampling properly, then you're going to have issues with your potentially increased monitoring requirements. you'll be in a violation. If you're, positives, if you're pulling more than 40, which nobody in here is doing that, if you have more than 5%, or like y'all, if you have one, that's more than your 5%, all it takes is one bad one to have a violation. And then we look at our acute risk. Public notification, TCQs aren't state regulatory, but always have to contact them before we start sending out notices, because they're gonna help us with the wording and who it needs to go to. If you have an acute violation, gotta let them know within 24 hours. Have a fecal coliform where you have a repeat that's positive, you gotta get notification out. They've changed it now, it's 30 days instead of the 14 days. So non-acutes, you just gotta let people know. And then the others in a year, right?
Monitoring violations are a year's out.
Right, so basically you're gonna put it on your CCR, your consumer confidence report. Even though that's for the state, and we've been talking about a bunch here in Tennessee, about what do we consider low distribution pressures and all. If you do have an issue with water outages, unacceptable sample results, if you're not maintaining your residual properly, we normally, in Texas, you gotta have 35 PSI in your system, that's normal operating pressure. Not supposed to have below 20 under fire flow conditions or main breaks or something. Y'all are just in Tennessee, just 20.
20,
right?
Yeah, it's minimum.
So that's minimum. They're shooting for 35. Boil water notices, anybody have to deal with that? Everybody has, that's a good thing if you haven't.
No, I mean, if there's a concern or something like that, if it's just a positive, or something like that, we don't require boil water
Right.
notice to be issued until we know that, hey, there's an acute MCL violation or something like that.
Have you had to do much of that in the past?
No,
10 years?
just, mainly whenever there's been maybe a mass water outage or something like
Right.
that for cross connections or a major emergency, like back in 2010, we had a flood in the Middle Tennessee area. There was known or suspected damage at mains, but they weren't sure whether or not contamination had occurred. So they did a boil water notice just as a precaution.
Yeah.
But yeah, boil water notices, we don't really, it's not an everyday type thing that
Well,
we.
that's a good thing. And frequency is great if people don't have to boil their water before they're consuming it, so.
I think in Kentucky, I think they issue a boil water notice for every line break until,
Wow.
at one point I think they did, but we don't do that.
Yeah, but that in the Virgin Islands, anytime they use water, they boil it. I mean, that was just you always had a fire going, you always had a pot sitting on there. One of the important things was once you finish boiling it, you gotta put it in refrigeration so you don't have stuff growing back in it and all that. But, yeah, luckily we don't have a whole lot of that. The little town that I lived close to not too long ago had to do a boil water notice, and that was a big deal. For them, because they hadn't had that in a long time, but they had main breaks and they had, I don't know if they had septic sewage contamination into it. And I think it was after the flood that they had down there that they compromised their system. Chlorination, what are we using it for? Obviously, we want to make sure that we have a residual or our stored water, not a demand. We're still going to have some demand in the system. We talked a little bit about it yesterday. If you're having problems in your distribution system keeping up your residual, then you got to look if you actually met your demand in the plant. I know there's a big issue with disinfection byproducts. Are y'all boosting your chlorine anywhere in the system, or is it just what's coming out of your plant? What are y'all using for disinfection?
Gas.
Okay, so you're using 150s, using tons?
150s.
Okay, but you don't have any boosters out? Okay.
We've got very few systems that have booster stations for chlorine.
Yeah. Yeah. And it can be beneficial if you're looking at water age, if you're looking at disinfection byproducts. You don't have to come out so hot out of your plant. What are y'all pushing out of your plant? What's your target?
Usually we go about 2.4, 2.5.
See, yes, and for us, that was coming out pretty hot, because we can boost it further out when you start to look at your secondary stations. But what's your TOCs running?
Usually we can claim a 1 on them, so.
Okay.
Yeah, you have your two.
So if you're coming off of a lake, you don't have the same issues as you would off of a river. See, that helps out a lot. So you can come out a little bit hotter and, you don't have some of that long water edge issue with it at high water contact. So, but knowing your system is really important. And it's very good. It's interesting, you're the first one in Tennessee that I've heard of that actually use chlorine, gas. Everybody else has been, the bleach, sodium
Pretty
hypochlorite.
good, number of systems that use gas.
Yeah.
I mean, a lot of them have, like you said, have been converting over to bleach because of the risk
Yeah.
management.
Yeah, you're the first one. What do y'all pushing today?
On poundage.
No, water, how much water are you
Water,
pushing?
about 2.4, 2.5. Now in the summer it'll go up.
Sure, yes,
But,
ma'am.
that's
Yeah.
usually it's about 2.4, 2.5.
Yeah, if you get too much, it's not practical to use bleach. You're gonna be almost 1-to-1 ratio or something, yeah, blending it, so, like I said, I'm not a farm that's for gas, I'm sorry. On the wastewater side, they actually were using, liquid. They had evaporators. I mean, they were pulling, they had they're 90, 110 MGD a day they were treating. And of course, on the wastewater side, you still have a huge demand, so, they were using a lot of gas. Then you have to dechlorinate it before you go to your outfalls. So they had a lot of SO2 stored also, a lot of it. So we want to make sure we have a residual, want to get rid of that demand. They were using a lot of UV down in the Virgin Islands. Most people didn't use bleach, or if they did, it was batch chlorination. Go out and pour some out in the cistern once a week or once every couple of weeks, something like that. So they weren't requiring a residual. I don't know what relationship they had where they weren't. Now the one big water system that they had, they would actually push and have a residual. And that was one using a desal, so it was pretty easy for them to keep a residual, except for some of their far reaches. One of the good things about chlorination, I don't know if y'all ever have a taste and odor issues coming off the lake. You have lake turnover, you gotta worry about.
We have lake turnover. We had a bad problem this year with it, but that's probably the worst I've ever seen.
Are you de-stratifying at your intakes? Do you have any kind of?
We pre-treat with potassium.
Okay, are you aerating anything right there? Okay, because there's some mixing devices that you can use, or aeration on your intake that'll help de-stratify that water, freshen it up and stuff some before it comes in. So you're using potassium permanganate?
Mhm.
That's nasty stuff. Are you using it in poly? You bringing it in as liquid or?
No,
Using
powder.
Oh, boy. I heard about to you. We, at that ASR facility, they had, when they did their initial pilot projects, real high iron, real high manganese levels. So they brought in and had a silo full of potassium permanganate. Once they actually got the wells drilled and started bringing in the water, iron was easy enough to get out just by a cascade aeration, and didn't hardly have any manganese, which was great. But now we had a silo full of potassium permanganate, and we had guys go in there from our maintenance division, suited up in B-level suits and stuff, and it was penetrating it. I mean, talk about chemical burns and everything, and nasty, having to wear respirators, because we had to get it out of there. So we wound up having a company come in, and they were able to take it out and utilize it, as a secondary source. But boy, I'm glad because they were going to actually batch it, make a slurry, and pump it out near your solid contacts. Didn't want any part of that, because you had to suit up every time you went into the silo. Whatever you have your batching process, so nasty stuff. How much are y'all using?
We used to be about probably a half a part or something of it. Well, I think it's up to 0.7 now is what they've recommended us feeding. We actually went from a saturator that we couldn't really control good to just the bulk. Well, it's not a bulk tank, but a tank where we can measure water per dosage of chemical.
Yeah, do you have a silo that you're dumping it into, or where do you get your powder? Oh, you get the
You would just get the little, 55 or something pail things.
Okay. Well, that might be a little easier to control than having a big silo where you got shakers and trying to.
It's not that bad, it's just messy, it makes a mess everywhere it's at.
What do you do for PPE?
Well, he's got all his safety equipment, like, the gloves, aprons, safety
he wearing a
goggles and
respirator?
stuff.
Is he wearing a respirator?
Yeah, he's got a respirator there too.
Yeah.
Usually we have one guy that's handling it right now.
The guy that's purple?
Yeah.
Call it Barney?
Yeah.
Yeah. One of the good things about chlorine is it'll help oxidize out a number of these components. Of course, the bad thing is if you're doing pre-treatment with chlorine, now you can have insufficient byproduct formation. So, a lot of times you're using alternates as your oxidation. We need to make sure we disinfect after repairs. You have calcium hypochlorite that y'all are using. What do you do?
Any pipe that we use that's off the field, we swab it with bleach and then put it back in the system and flush it and get a sample.
Okay. So you're pulling back teas and residuals and all?
Yeah. Every time that we cut it, if we got a negative pressure.
Right, yeah, if you do it hot.
Yeah, that's part of our, rule requirements, that if you can maintain positive system pressure until you get down to the main and clean the area before you actually cut off the system pressure, then we've allowed that you can, swab the interior of the replacement main and the cut ends.
Right.
And go ahead and flush it and pull you back two samples. But if you don't maintain positive system pressure, then we want to see a slug method of it.
Okay, interesting. So if you're gonna do a slug, where are you doing your introduction?
Just, I mean, that's one of the reasons a lot of systems try and do it.
Sure.
That it maintains positive system pressure, because sometimes there's not a good place to put it in. You
Yeah.
have to pull a meter or something like that and try and dump it in, or
that's
put it in at the repair side, and you're trying to figure out how to push it back and forth to get the slug to
You
go.
don't wanna send it, you don't want to send
Exactly.
it highly concentrated. So yeah, that'd be a challenge for sure.
Yeah, I mean, there's some systems that have gone to pumping it in,
Yeah,
like
gas
a bleach
feed.
solution.
Oh,
Or,
okay. Yeah.
some gas, but
Mhm.
they'll do like a bleach solution and pump it in that way, but, I mean, not all systems have that capability, and they've got to rely on HTH or
Yeah.
calcium hypochlorite to.
What kind of contact time do you have to have? on a slug?
Usually, we fall back to the 300 parts per million for 15 minutes, but we also recommend that, hey, if you can keep it off longer,
Yeah.
and then try and interpolate, well, for halving the dose, if you double the time, sort of like that, and I think you get down to something like 25 parts per million for 4 hours, as far as just having it in contact.
Yeah.
Try and use a lower dose if you can,
Yeah.
so.
Yeah, because we had a big issue when we were were building that pipeline. They had a 60-inch pipeline, 30 miles long, going from San Antonio all the way down to the ASR facility. And so what they did is they did slugs, and they would move that slug down and re-chlorinate it and all that. And but then when you get to the end, they have to dechlorinate it. You can't just dump it on the ground.
Yeah.
So those are things that you have to consider when you're dealing with. I don't know if y'all are having to. If you're able to keep it under pressure and you don't have to worry about slugs, boy, that's a huge benefit, because it's a pain trying to do something like that. Then you're out. You still got people out of water for how long?
Yes.
So those are big issues. Interesting to see what each state kind of requires. Yeah, the guys that if they were out there doing repair, and if they were able to keep it, like I say, at least until they got it clean, a lot of it was HTH and let it flush and wait for your residuals and all that kind of stuff. Sometimes you got to really extend your shutdown to make sure you got your hydrants in there and stuff like that. So, hypochlorites, either sodium or calcium. The way I remember it, sodium chloride's on your table, bleach is in your house, so sodium goes together. Normally 6 to 12 or 14%. So it can take a whole lot to have that disinfectant power. Calcium hypochlorite typically about 65%. Chlorine gas 100%. So you can see where the benefit is depending on what y'all are pushing. What are y'all using out there, Robert? You're using bleach. Do you have it brought in? Yes, sir. How much are y'all using? Because you have what?
Right now, just about a gallon a week.
And you got a metering pump out there that's pumping it in? Okay. You have a storage tank out there that you're feeding?
Yes.
As it comes out of your well, going into your storage tank?
Yes.
people are y'all serving? Because you're, sir?
Less than 1,000.
Yes, sir. And are y'all on two different systems?
No, we're same system.
Okay. And you said something about the roadside? Was it a?
It's a
The
restoration
restoration
area.
area.
Okay, all right, so y'all are both serving the same? Okay. Yeah, and a lot of those, you know, like say you're out in the middle of nowhere or something. Y'all getting the poly tanks, or you have a little tank that somebody comes in and fills up, or you buy bottles and pour it in?
They just buy cases of bleach.
Yes, sir. Okay. And we're gonna get into talking about that, but one of the things that's real important, like on the coatings, is making sure that it's NSF approved. Anything that goes into the water or can potentially be in contact with the water, any kinds of oils, bleach, anything else, needs to be NSF approved food grade. Because otherwise, we had on our SCU, our solid contact unit, we had a big chain drive for our rain system, and they put in a drip system to lubricate it. Well, you gotta make sure, because it's potentially gonna, anytime it rains, it's gonna be right down into your water. So, had to make sure we had food grade, you know, just couldn't go and buy, wait or whatever, somebody found cheap on at the store, to put in there. When you're making pure chlorine, they're actually, and that's the same thing that they're using for the on-site sodium hypochlorite generation. I don't know if anybody's doing on-site bleach.
We've got a few systems that we're doing and some systems that are thinking about
Mhm.
going to it. So it's, I'd say it's growing, slowly growing in
Yeah.
popularity.
Yeah, yeah. We put in a system on the Riverwalk in San Antonio, pumping a historic pumping station down there, and they had ton containers. And of course, low-lying area, highly populated area, so tons of bleach or tons of chlorine isn't necessarily the best. So they went to the on-site generation. Problem is that we have really hard water, so we had a lot of problems with our ion system, trying to get the hardness down. I mean, we're pushing over, hardness is 210, something like that. I mean, it's something big. Yeah, you look at, and if you're coming off the lake, what do you have, 20, 30?
On the hardest, well, we use titration, though, usually ours is higher than that,
Uh-huh.
you know, right offhand, I can't
Yeah.
think,
But I
it's
would-
about, I wanna say 20, or they're about on, I really can't remember right offhand.
I would imagine coming off of the lake that you wouldn't have a whole lot of hardness in your water.
Oh, well, no, it's higher than 20, I wanna say it's about 70. I think,
Is it?
or something,
We
yeah.
would run about 110.
Oh, yeah, I think it's
Off
about
the lake?
70, something like that.
Interesting. So I wonder if it's being fed, because I know we talked about there's some karst aquifers in the area. I wonder if they're spring fed into that lake, because that would be a contributing factor, or whatever the matrix of the lake is, if it's
I
a
mean,
limestone bed.
Just, I mean, from what I've seen, hardness here is
Moderate.
about, yeah, moderate, but then you get into Middle Tennessee, and, I mean, there's like, in Rutherford County, hardness would be upwards of 300.
Wow.
So,
I think that's what
Murfreesboro is
Tennessee-
the only plant in the
Kidney
state that
stuff.
does solid water.
You know, that's a big issue. That's an interesting point. What Robert mentioned about with talking about real hard water and all, about being the kidney stone capital
Yeah.
in Tennessee.
That's all, I've always heard that's what causes it, is our hard water.
Yeah.
That's why we have so many people with kidney stones.
That's interesting. You know, start looking at water chemistry, love the dynamics of it and how it affects your health. You know, people think that, oh man, if I could have a system to take everything out of the water, well, that water's not good for you. You know, if you have ultra pure water, that's not good to consume. You need minerals. You don't need that many minerals, but you do need minerals. So when they're doing through electrolysis, one of the things that we talked about a little bit yesterday, they had some those carbon container units down in the Virgin Islands that they had shipped in, and they were doing on-site generation. But one of the big important components of it is it's got to be a cooled area and it's got to be properly ventilated, because at higher temperatures, instead of producing the sodium hypochlorite, you're producing pure chlorine gas, and you're producing hydrogen gas, which is explosive. And they mentioned that there was an explosion not too long ago, a couple of years ago, in one of the locations here in Tennessee. Somebody lost their life. And it's because it wasn't properly ventilated, probably wasn't cooled properly. You start to produce hydrogen, and Obviously you got a lot of electricity in the building, you got bad environment. So those are things to be really careful of or consider when you're looking at alternative methods. But it's a neat system, and it's, especially depending on your raw water or your whatever your processed water is, it can be a really neat system for you. Chlorine is amber in color when it's under pressure or it's cooled properly. Obviously, we know it's toxic. Do y'all have contact with the fire department for emergency response? Do you have anybody that does it in-house?
No, actually, we had a bad chlorine leak here, what, a few months back? And of course, the operator there, he contacted the fire department, and they contacted hazmat, and got everybody into the tank and stuff.
Who does the hazmat? Was it outside?
It's from our Rome County.
Wrong County emergency, they got their own hazmat team.
Okay. Do they come in and look at your facility? Have they ever toured it before?
They've been
Outside of the
there,
emergency
but
response. Outside of the emergency response.
yeah, they toured it that day.
Yeah. That's
They
not the
have
time to
been
do
there,
it.
but routinely, no.
Yeah, that's something that's beneficial. It's not always easy to do, but to have them come in, I don't know what equipment y'all have for your own personnel, even just to escape, if you've got a full face with respirator cartridges on there, when you're doing tank changes and stuff, even a 150-pound has a lot of potential in there. Much less the big ones. We did all our own emergency response, so we're all hazmat trained, had all the SDWAs. We practice real regularly with either the A kits or the B kits, depending on what you were using. And then we would coordinate with the fire department to come in, because they had a real nice hazmat team, but they were our secondary, because it was our facility. We knew the equipment, we knew the layout, so they would actually just come in and back us up in a situation. Luckily, we didn't have many of them, but every once in a while get a leak going on or something. Nothing catastrophic. So we talk about 150-pound cylinders, ton containers. Then they also come in rail cars. City of Dallas uses rail cars. That's a lot of chlorine to be moving around the country. And a few years back, they had a big derailment outside of San Antonio, and it was a rail car full of chlorine gas.
Metro Nashville use rail cars?
Yeah, Metro Nashville uses rail cars, and I think they're looking at, they're relatively close to downtown Nashville, and they're looking at doing on-site generation because of that.
Yeah. You start looking at your risk management program, start looking at liability. They had an issue with it in San Antonio. Luckily, it happened outside of town, but the wind was blowing, prevailing winds coming out of the south, blowing it toward like the SeaWorld area, which is a lot of exposed population. Found out how inadequate the 911 systems were. Figured out how what kind of infighting you have between the local, rural volunteer fire departments, and then big SAPD SA fire department comes out, and they're big boys on the blocks, and they're going to take over and run the show. They didn't know the area. They had people had called in and they wanted to do shelter in place. Those people perished. The people that decided they were going to get the heck out and drove out through the cloud, they survived. Had some injuries and stuff like that, but it went cross country, through the fields and stuff to get out away from that. So it's just interesting when you start looking at responses, what you're up against. Do y'all have any kind of scrubber system?
No, we just got the kits and stuff like that. No, we don't have any kind of scrubbers and stuff.
And they're going a lot now to like a chemical media instead of the liquid, sodium hydroxide or something like that to help neutralize it. But those all take maintenance. It all takes time to stay up with it. Proper ventilation is a big thing. Forced ventilation from the top and being able to ventilate it out. I don't know if y'all have any kind of chlorine leak detectors or something like that. Handheld meters. Those are real important components. If you can walk up and tell that you got a problem before you have to go in, that's really nice. We had an issue where they designed a facility. If your header system started to vent, it would vent out the head of hose running right out by the front door. So you walk up there to look at your meter and see what's going on, and the vent's right there. I'm like, I don't know who designed it, but it was not good. We kept having problems with regulators getting sticky and they start venting on us. So anyway, obviously we rerouted it out the back, put it in a vault, put it with a leak detector in there, so it's being trapped underground in a low spot, and then sending us a signal. I'd rather have a signal than to go out there and get a face full of it. So we start looking at withdrawals. If you're pulling with a vacuum on the 150s, you can pull about 1 pound per day, put it pretty Fahrenheit. Sometimes you can get up to 8. I don't know if y'all are pulling vacuum or y'all running just off of regular pressure.
Pull vacuum.
Okay, so if you're pulling a vacuum, that's about what you can figure. If you're just using off of the pressure of the container, you get about 42 pounds per day at 70, and off of the 10, you get about 336. If you are using hypochlorite, using the calcium hypochlorite, have a mixing tank, you're going to pull off your supernatant, and then you got to have a way to meter it in. And then of course the solution is going to change periodically, it's going to be 65 plus or minus, so you're just going to have to adjust your feed rates on a regular basis. And there's little small systems you're going to use that. Gas chlorination, y'all are at least familiar with using gas. You got your water flow through there, you got rotometers, that's where you're going to be able to tell what you're pushing. What are y'all pushing in pounds per day, you know? I know you mentioned that earlier.
Probably about 70 pounds or something.
Okay. You have redundant systems, you've got a standby. Here's a quick diagram of it. Obviously pulling the gas. At the big wastewater plant, they were actually pulling the liquid side. And so that's interesting when you start dealing with that, because it's a lot more potential problem when you're pulling off the liquid side on the tank container. So simple straight setup. A lot of issues for leaks, you know, so proper POs. Talked before about the dosage and the demand and the residual. So dosage is how much we're putting in, demand is how much is being used up, and then of course we need to have something left over. I think paychecks is how much we're getting the dosage. There's always a demand, mortgage and vehicle payments and all that stuff, and hopefully we have some left over at the end of the day, at the end of the week. So that's an important component of where we start looking at it. Most of the time we don't know what our demand is unless we back calculate, figure out what we're using. It's easy to tell how much we're pushing. It's easy to tell how much we have left over. We're looking at residuals. If y'all are just using chlorine, you're looking at free. In Texas, if you're using surface water, you're combining it typically with ammonia, and so you're going to look at your chlorine residual. I'm used to free, or in the wastewater, you're looking at total. Is what you're normally looking at, and on the wastewater side. So that's your free and your combined added together. We have our minimum requirements of 0.2. Your maximum is 4.0. And then y'all are testing, how often do you test in the plant? Every couple hours? Are y'all 24/7?
Well, what we're required to do is like twice a day, but we do it, we continuously, it's monitored.
So you have online?
Yeah, but we test about every hour, so, I mean, we'll watch the monitor, if we see it start to go up or down, of course, it's all set on alarm systems too, if it gets
Okay.
below a certain point or above a certain
You're
point.
using colorimetric? Is it like a CL17 or?
Yeah.
Okay. They're a great system, requires some upkeep, you know, some preventative maintenance and corrective maintenance when they go bad, but that's a good system, like the CL17. They're doing some now with oxidation reduction potential, ORP systems and all. Kind of interesting how they're moving away from some chemical additives and stuff, but pros and cons with it all. Y'all are testing what, once a day for your residual? What are you using? Do you have a handheld? Do you have a hot colorimeter, or
No, he's which one have you got?
you got a color wheel, or?
No, we use
Digital.
Yes, they do.
Color.
I don't remember the model.
Yeah, okay. Yeah, they, I've seen the test strips, which are like, I don't know, way back, color wheels. There's some guys in San Antonio, especially on the inspection side, and they would not give up their color wheel. And it's old and faded, but I don't know, it was near and dear to their heart or something. They just really were against electronics. And I'm a big instrument guy, so I'm a real big proponent of it. But it's also important to know how to calibrate it, because how can you verify that data or that number that you're getting if you don't know how to calibrate it. So are y'all doing primary standards, secondary standards?
On the CL-17.
No, well, for your pocket colorimeter for your,
Yeah, electronics, yeah, we calibrate it every time we run a test with the, I guess, secondary, I guess.
you have the gels?
Yeah, we've got one of those too.
The secondary standards are nice.
We don't have a requirement that they calibrate the instrument at any certain time. We just have a verification as far as the CL-17.
Okay.
And then on the handhelds or the benchtop instruments for the chlorine, I mean, it's usually whenever, you know, Labtronics, which is a lab certification company comes in, they'll do I guess a calibration. But what we've been told is that, especially on those handheld digitals, that you have to send it back to Hawk for recalibration. You can check it with the
Right.
standards, but to actually do that calibration, you
Yeah,
have to send it back to Hawk.
all you can
so-
do is just verify the accuracy off of a known standard. Yeah, I agree.
We still use the titration thing up to here a few months back, and it messed up, and we went to we had some of the handheld ones, but that's what we're using now, just because that other, but it was accurate, I mean.
Oh, yeah.
It was old school, but it was
Yeah,
accurate.
well, I mean, you get in when you titrate, I mean, that's, if your chemicals are good and stuff, that's real accurate, so, yeah. Yeah, I'm a big proponent of a daily log or something like that, where even if you just have the secondary standards, and they'll last you for 2 to 3 years, depending on when they send them out. Real easy to check, real easy to verify that it's at least within range. If you have something real goofy, you know you gotta do something else about it. So part of your quality assurance program, quality control, I'm a big proponent. We did primary standards, and then periodically we do a secondary, but it was cheap enough to buy our primary standards, and we did it every day. It was just our process. But, you know, it's easy to look at a number and say, hey, you know, that's a great number, but is it valid? What confidence do you have in it? So, if y'all are doing that, that's great. So we look at some of the measuring devices. We need to make sure that it's EPA approved, DPD, it's an approved method. A little strip, no. Color wheels, if they're sitting out for a period of time, they're gonna fade.
Look at some strips now that are EPA approved.
Yeah, how are they now?
I want to say Testure or something like that. It's actually in our rules that you
Good.
get some test strips
Uh-huh.
that are EPA approved. And I think a lot of systems use it out on the distribution side for whenever they're using 10 or 15 or 25 parts per billion
Yeah.
or even higher, because that way you can tell more easily. So I think there is one
Okay.
test strip that is EPA approved.
Yeah, because a lot of times they go down to the pool supply and pick
Yeah.
them up something and that's lacking, but it's interesting if they're able to utilize that, because yeah, otherwise you gotta know how to do dilutions and then calculate it back out if you're running a real high residual or something. Has anybody ever seen a residual flash where it goes from white to white again, like that? Yeah, if you're running real high residuals, you gotta watch it carefully, but it'll flash on you, you're like, well, I don't have anything in there. No, you probably got 50 plus in there. So, DPD will flash on you real fast. So I don't know if anybody else has witnessed that, but I have. And it was unfortunate because it's not where it was supposed to be.
Yeah.
And then you're like, oh my God. So now you gotta really work on stuff. But we need to make sure we have improved methods. The reaction of chlorine and water, you know that water is going to disassociate with our hydrogen and our hydroxide ions. And then we're going to have chlorine out there. So the chlorine and the hydroxide ions are going to combine and make hydrochloric acid. And that's the real strong disinfectant. That's what's really doing the work for us. Hydrochloric acid is just adjusting our pH. That's the hydrogen and the chloride combining. So what we want to do is be able to reduce or destroy the cell itself, the pathogen. Looking at chlorine demand, one of the important concepts of this is breakpoint chlorination. So when we first started adding our chlorine in section 1, we're just as being consumed everything that's being added in there. And then we finally start to get a little bit of residual in area 2, but that's our combined. So if you're running chloramines, you actually want to be up on the high end of 2 right before you move into the section of 3. And that's where you're going to run that. And in section 3, you're actually, as you continue to add your chlorine, your residuals going down. And so a lot of times when people have taste and odor issue, man, like that chlorine in the water smells like, a swimming pool, you're probably in area 3. And your first instinct is to back off of your chlorine feed. You actually need to feed more. You get breakpoint chlorination. When people talk about the things smell of chlorine in the water, unless you're just really, really hot, you haven't reached breakpoint yet. So once you reach breakpoint, now you're getting a response as your feed. You're increasing your feed and you're seeing that response increase. So that's a really important concept depending on what type of system that you're running. If you're using your chloramines and things like that, you want to make sure you fall in a certain range. If you're having taste and odor issues, see what your feed rates are, see what your residuals are, make some adjustments and see how it's affecting. So, Class B and Class A operators, Bs, you have to be able to draw this out and label it. Class A, you got to do an actual, like a summary of it, a little essay. So, but a real important component of our treatment. So look at safety. Obviously, we need to make sure we keep our equipment separated. We need to keep it up to date. If you're putting on valves and all that, use new washers. Are y'all using lead washers?
Mhm.
Yeah, you need to have some way to recycle those, but always put on a new one. Using old ones is going to cause you a lot of problems. Start talking about redundancy in our system and capacity. We have to have 50% capacity over what would be expected under peak demand and peak flow. We have 50% above that. Because chlorine is heavier than air, we definitely want our stuff up above ground. We don't want it down in low-lying areas. We want our containers and our rotometers and all, if we can have them separate. Some real small buildings, you can't. If you can, that's obviously preferred. Got to bring air in, force the air from the top, and let it be pushed out the bottom. Chlorine, I don't know if y'all have heated rooms. Do you have heat trace?
We put a heater in there.
Did
We
you?
did have one that was overhead, but it just wasn't working accurate, so we just put a little space heater. The room's small enough that it works.
Temperature's real important. You get it too low, you're not going to feed. I would imagine that'd be the bigger problem here. Texas, we don't have a whole lot of problems, especially down south. It's hot enough most of the time that you want AC in there. You got to have scales to be able to determine what you're using. You got to document it. It's important for a lot of reasons. One of them was the state will tell you that you need to have a scale. That's a good reason. But you want to know what you're feeding on a daily basis. If you have big changes, you can go back and troubleshoot and see what's going on. You need to have your stuff locked. Homeland security is huge. Even for little small systems, there's always that potential of inappropriate activity, be it domestic or foreign terrorism. And so, again, as public servants and public health, we really have to make sure that we look at our vulnerability. That's a big component of it. If you are running hypochlorite, you want to make sure it's covered. If you can have it protected from the sun, because UV is going to degrade it. Do y'all have y'all's inside of a building? So that's important. If you have more than a certain amount, you're going to have to fall under the risk management program. Luckily, I don't think y'all are above the 2,500. If you don't have to be, don't, because it's a lot of extra work, a lot of extra headaches. You should have evacuation procedures. There's some neat programs online that will help look at drift models and all, depending on what type of chemicals you have, prevailing winds in your area to see who might be affected. If you're out in the country, that's great. You're just going to have some extra beef. But if you're in a populated area, or if you have residential that's close by, it can be a real issue. So we're talking about dense population. Luckily, most of them are out, but the city grows out to us a lot of times too. If we have a leak, we're using ammonium hydroxide. We don't want to spray it on there, but we want to use the gas coming off. It's going to be white smoke if you have a leak. And are y'all using masks whenever you do changeovers and stuff?
We have them.
Okay. It is highly recommended because it's after the fact. You get hit in the face with a pigtail break or something like that. Something doesn't seat well. It's for escape, and I know it gets to be a pain. We would put on chem aprons, chem gloves, a respirator, things like that. And then it gets to get old after a while. But all it takes is getting hit in the face once with a high dose of chlorine, and you'll wish that you had your gear on.
Yeah.
So,
Well, actually, they took our gear away. We had SCBA's and everything, that's false, that's security. Even took our escape mask. At a bridge. Yeah.
wow.
You don't have no kind of security at all.
If you got a leak, you're hurting. You can't get in there to do it, that's fire department's job.
Yeah, well, and I agree that, because if you have a respirator, you can't go in and repair a leak. But if you're in there doing a changeover and you have a leak, it gives you the chance to get out without being exposed to it. So, but yeah, I mean, I wouldn't recommend somebody, because you're gonna use up that cartridge in a heartbeat with a high concentration, and now it's bypassing, and you might as well take a hit off of the off of the cylinder of the container or something.
Yeah, our emergency operation plan book tells us really where to get out and make a phone call.
Yes, and really, that's if you're not trained for the actual response. And I mean, that's what, like if we had a leak, we would go out, we would group up, get our plan in order, draw all our notification and stuff, and we had a scrubber system, but then we'd set up and go in and take care of the response. But it's just an escape, but PPE is so important. And I know you're not there right now, but man, taking it away.
It's changed.
But you gotta know how to use your PPE, and you gotta, and like I say, it's great to have heroes, but you don't need dead heroes. You gotta get people out and let the people that are well trained do it. And a lot of times we think the fire department and they're trained real well for certain things. They're not always trained for our industry. That's why a lot of times it's beneficial to have somebody who actually works at the facility, knows it, has that coordination, has those skill sets to be able to do it. So, yeah, that's a big issue.
We actually have a volunteer fire department that's probably one. How far from the plant is?
Yeah, probably 150 foot.
Yeah, I mean, it's not, I mean, it's right across the street, you go them one way and us, so I mean,
Yes, ma'am.
they're there pretty soon.
Yeah. I found it real interesting in, on St. Croix in the Virgin Islands. They had their huge power plant, they had their desal plant and all that. Right next door was their main fire department. Okay, if you had a massive explosion, you've wiped out your main responders. I don't know who set that up, but I would not have them located. I mean, literally, there's a fence dividing the two properties, a chain link fence. It didn't make any sense that, I don't know if the land was free, I don't know what the purpose was, but I would not have them, I would want them to be, not on the other side of the island, but I want them to be a ways away, so if there is a catastrophic failure in that facility, you can at least have somebody respond. You can take them home. So all their equipment and everything else. The Chlorine Institute is a real good source if you have questions and stuff on chlorine leak. If you do have a leak and you don't know how to deal with it, you can always contact your supplier. Talk about entering a chlorine room. Training is important. You need to have either supply there, SCBAs. You gotta have somebody that's gonna there to help you rescue in case you get in trouble. You gotta have the right repair equipment. Do you have an aid kit? Do y'all get out and practice with it? Can't stress enough that having that kit doesn't do you any good if nobody knows how to put it on.
How would we even go about doing that? Would we have to go to like a fire department or something like that to let them, or actually to the Brent Tank or something, school, and let them, I mean, I've sent some of our guys to the Brent Tank schools, but I mean, and I don't really know if they've been trained in that class to use it.
Their Chlorine Institute has, they probably have some training video stuff available. One of the things I would do is I would look at who would be your responders, and it's not the volunteer guys, it's whoever they're coming with, from the hazmat group. Have them come in, use an empty cylinder that you've kept around. Sometimes you can buy cylinders that are set up to actually work on simulated leaks, which are very beneficial, not a whole lot of money. And you can simulate a couple of different types of leaks. Have it in a program where somebody opens up the kit once a month, once a quarter, something like that. Pulls everything out, goes through, does an inventory, has it sealed. Make sure that they're not over there borrowing tools out of it. You know, it's gotta be dedicated. Don't have it in your flooring facility, in the flooring
Yeah.
room. Have it in a separate area, because once again, if you got a leak going on, now you gotta go try to find it in the dark, or have it in close proximity. We actually had 2 kits. We had one in our big maintenance bay separate, and then we had one on a rolling cart that was in our facility. So if you went in there all suited up, you could just roll it. It was, all you had to do was just roll it right down the bank, because you had your big bank. You just had to roll it right to where you were at. You could open it up, have workspace, and you could work on it, and you were up off the floor, because again, it's heavier, so if you were in a big leak, you would have at least a better chance of seeing. Yeah, go through some training, and then once you figure out how to use the different components of it, go and practice that. Buying a dummy tank is like the way to go, or a dummy cylinder. That's really the best option for you, because you can actually put it under pressure, under water pressure, and you can simulate various types of leaks. You know if you get it sealed or not, because if you're still blowing water out, then you'll be blowing gas too.
That's one thing, and something we could probably do whenever we do an inspection. I mean, our water supply rules don't really cover, you know, the safety and all that, but I think we could probably say, we don't see an SCBA or anything like that. You may want to check with, I guess OSHA would be, Tennessee OSHA would be the one that would be in charge of making sure that stuff is there. So that's what we could probably do as part of the inspection, is to put that comment in there without, saying, I mean, we really don't have any authority to say this rule says this.
Yeah.
That's what we could probably end up doing on inspections.
Best management practices, BMPs, are what you want to set that bar at. And even though we weren't regulated by OSHA, we still we followed OSHA guidelines, because that is the industry standard. As a utility, they have to provide you PPE, which is required, and there's liability issues if they don't. So, and that's an important component of your safety. And then, so now you have them, you need to have them. I mean, there's so much to it. I mean, you can have a whole class just on it. In fact, I'm going to New Jersey to help them do O&M programs, because they just really don't know how to build an O&M program. Even something as simple as pulling up a manual and figuring out the frequency and the types, so, but there's a lot to it. So you need to make sure that people have dedicated equipment, not just one sitting out there that anybody walks up and uses. Dedicated equipment. You need to know the lifespan of the cartridges, make sure the cartridges are the right kind of cartridge. That's really important. What's the care? Where do you keep them stored at? Access to them. What's your SOP on when do you use them? And then you have to enforce that. I mean, it's all about safety. Because I know at the end of the day, the people that I work with, I wanted them to go home too. I want to go home. I want to have fingers and toes. I want them to go home with the same fingers and toes that they showed up with. No pneumonia issues from chlorine exposure and all that. So, as a manager, superintendent, it's very important to promote that in your organization. I don't know if y'all have an employee-driven safety program, but that is a huge component of a well-run system. Is let your employees be a driving force. Obviously management involvement is very important, but employees are out there every day seeing these different ideas, seeing these different problems, and let them be a big part of helping to look at them, identify them, and then try to solve them. And some things are short-term and real easy, some things take a long time, but those are the more important aspects of it. So practicing with your repair kits. A monthly, are y'all 24/7 at your facility?
No,
So
we
Monday
just
through Friday?
pump till we get our tanks full, which is about an average of 10 hours a day or something.
Okay, all right, and then you come back the
Shut
next
down,
morning and
yeah.
start it over. What about weekends?
Yeah, we work
Okay, so
7
you're
days.
7 days, but not 24?
Yeah.
Okay. Saturdays or Sundays is an awesome day to, if you got staff there, to, you don't have management, you don't have maybe some of the other demands, to pull out and then practice on a cylinder or something like that, especially if you can get a W one. They recommend having a harness and lifeline. We never did. We had backup guys. But if you're just looking at escape, if you're not looking at actual going in and doing repairs, get out of there, make a call. set up your perimeter. First aid, if you do get hit with gas, you wanna get them out in the warm air. Obviously, the chlorine is cold, you wanna get that temperature up. Try to have them sit up as best so they can off gas. You do need to make sure you have showers, and even like with using bleach and metering pumps. I don't know if y'all have a shower nearby, but that's something that's important to think about. Because if you get sprayed under pressure, especially in the face, what are you gonna do? Where are you gonna go? And you know that stumbling around trying to figure out where you're at is not the time to think about, oh, I need an eye wash station or something. It's real easy to set them up on a sink or whatever else. There's devices out there that can be real beneficial. Especially with your clothing, if you get a big hit, it's impregnated in your clothes, it's still gonna off gas, so you're still getting it in your face. If you're sweating, now you're making hydrochloric acid on your skin, not a good thing. So you definitely wanna get out of those clothes and wash. You gotta flush 15 minutes. The milk is really the best because it's a coating. It's also gonna neutralize the acids that are forming, because when chlorine gets into you, you got a moist environment, it's making hydrochloric acid, it's making your throat, your eyes, your nose, your lungs. It's pretty bad stuff. And if you get a real bad hit, obviously you're gonna need more help. Talk quickly about alternative disinfectants, chlorine dioxide, ozone, and then UV. I don't know if much y'all using chlorine dioxide much in the.
We've got, I think, maybe 2 or 3 systems in the Knoxville area, and then probably 2 or 3 in the Middle Tennessee area that use it. So it's not widespread, but
Right.
I mean, there are some that use it.
Yeah, there's some benefits to the chlorine dioxide, real good disinfectant, taste and odor, things like that. What the biggest issue is you got byproducts that are being formed. So you got levels, maximum levels that you really gotta watch. If you exceed them, boy, you got a lot of headaches out in your system. Occasionally you gotta go and do burnouts in your system, go off your chlorine dioxide, go to chlorine, burn all that out, and then go back. In Texas, it's 0.8. I believe that's a national standard. And can't have over a 1. At 0.8, you're already starting to get into the monitoring. Some are just using it on the pre-treatment, some are using it for actual disinfection of the system.
That's most of what's been used here is pre-treatment, and then they'll leave the plant with chlorine.
Right, and so what they're doing is they're minimizing the disinfection byproducts by using an alternate disinfectant on the front side. Have to generate it on site, so that's an issue for you. Ozone, superb, awesome.
I don't think we've got any systems using those
Yeah,
anymore, so.
Arizona is using a bunch of that. I guess they got deep pockets, I don't know. But they're using some of that as some of their pre-treatment. But it has to be generated on site, really, really powerful. But no residual is left, and takes a good bit of expertise in running the system. And also, because of the issues with ozone in the atmosphere, you can't just off-gas it. Whatever it is, it has to be captured under vacuum. It has to actually be converted before it can be discharged. And of course, you can have some aldehydes being formed. It doesn't leave a residual, so it can't be your final. It can be used in your process, but it can't be your final. UV is beneficial. I'm surprised how much they were using it in the Virgin Islands. It's like they just see the little light in there, and I guess it gave them that warm fuzzy feeling of, the light's glowing, but what's your penetration, what's your turbidity, what's your effectiveness of it, and if you don't have a residual, how do you have confidence that water's been treated properly, other than you pull a back tea and you find out 5 to 10 days later that it wasn't. So that's so we're required to have residuals. You don't have any disinfectant byproducts because it's not a chemical reaction, it's a physical reaction, and it's actually denaturing the DNA in the cells, the UV, and that's what happens when we get skin cancer from sun exposure. It's mutating our DNA. So we're making them when they're not able to reproduce using UV. I don't know if anybody's using UV on the water side.
We've got one system that has it installed, and we're looking at not using it anymore because of the energy costs.
Energy cost is a big one, maintenance on it, you gotta use some pretty nasty acids to clean them, clean your cords and stuff like that. The bulbs are expensive, you gotta keep up with your, bulb runtime hours and all. We had some at one of our small, plants, and it was a lot of work to keep that, to keep it up to speed on it. Turbidity is a big issue, you have any kind of turbidity in there, and, it really affects your penetrating power. It is lunchtime.